So welcome back to the channel guys. Hope you are doing extremely well, and this is your very own mass coder this side. So we're going to solve the practice question number 7 of the linked list series. The whole linked list learning series is already been uploaded, and above that question, 6 question for practice has already been uploaded, and the series will continue to do so if you show the love continuously, right? Now the question is reorder linked list, and it is actually a very beautiful problem. The problem says that you have been given a linked list. This is the head of the linked list, of course. And now if I try to mention the indexes of the linked list, such as this is the position number 0, this is position number 1, position number 2, position number 3, position number 4, position number 5, right? Suppose this is n minus 1 position. If the length of the linked list is n, this is n minus 1 position. Now the question wants you to rearrange the linked list such that the 0 node comes at the first, followed by the last node, that is n minus 1, followed by the first node, followed by the n minus 2th node. This is n minus 2th, right? And this is n minus 3th, this is n minus 4, this is n minus 5, this is n minus 6, correct? So followed by n minus 2, after that follow the ones, that is 2, then n minus 3. Now as you can see, after 2 it will go to n minus 4, the third node will go to n minus 4, 2 will go to the 3. These two nodes are already in the part of the linked list, so we have to stop here. So you can see my answer linked list is looking something like this: 1 followed by 6, followed by 2, followed by 5, followed by 3, and then followed by 4. This is my answer linked list. I hope that you are clear with this. You have to take the first node from the first part, followed by second, followed by last. Continue here, continue backwards, continue forward, continue backwards. As soon as all the nodes are traversed, stop. Okay, this is the required part. Now, when you see this problem in the linked list, it is actually kind of difficult to deal with, right? Also, the above added constraint is that you have to do it in place. You don't have to use any extra space, right? Or one extra space you can use, right? Now, I say that relax your mind and convert this linked list into an array. Convert this linked list into an array. Suppose your array is 1, 2, 3, 4, 5, 6. Suppose this is your array, right? Now, if I try to do that, leave the in place part. If suppose this is your input array and your output array, you will say, I will devise the same array of same length. Now what will you do? You will keep a start pointer here, you will keep an end pointer here, right? Take the value from the start, put it into the array. Take the value from end, put it into the array. Move the start here, move the end here. Again, 2 here, 5 here, move the start here, move the end here. 3 here, 4 here, move the start here, move the end here, and as soon as start becomes greater than end, stop. Start becomes greater than end, stop, right? You can see 1, 6, 2, 5, 3, 4 is the array you want as your answer, right? But it is actually very easy in the case of array. Why? Because I have direct access to the index of the element. But in the case of linked list, I actually have to traverse. Which increases my time complexity. So you can see after putting 1, I will have to traverse and the whole length that I for coming to 6. After putting 2, I will have to traverse the whole length minus 1. After putting 3, I will have to come to n minus 3. So it is actually going to O of n square, right? O of n square. But in the case of array, it is O of n. My point to you is, can you reduce the time complexity of O of n square in the case of linked list to O of n, similar to what we saw in the array? Yes, but the approach is not going to be exactly same like this. It is going to be very different, right? So what I'm saying is 1, 2, 3, 4, 5, 6. This is the given linked list to me. Now the brute force approach says convert this into some kind of array. That is, this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5. Now map the indexes to the list node. Use a map of type int to list node. Name it as MP. Now what will you do? You will say where temp is here, you will say cur equals to 0 for temp. So temp equals to head, cur equals to 0, and now while my temp is not null, what will you do? You will say MP of cur equals to temp. Okay, after that what will you say? You will say temp goes to the next node and cur plus plus. Now The problem of traversal reduces. The problem of traversal is actually reduced because I can just take the node 6 from the map. I can just take the node 6 from the map. What is my start here? My start is gonna be 0 and my end is gonna be cur minus 1. End is gonna be cur minus 1. And now the question is exactly similar to the array. The question is exactly similar to the array. You can use that. What is the time complexity? So time complexity is n log n. Why? N is the linked list length, right? But why n log n? Because for putting values into the map, I'm using a log n time, right? I'm using a log n time. This is my brute force approach. That is easy, right? What can you do? You can do exactly similar to this. Just instead of putting into the array, join the elements into the answer linked list. But I have an optimal approach also, which is not using any kind of extra space. Any kind of extra space. Optimal approach says that for the given linked list 1, 2, 3, 4, 5, 6. I need one node from here, one node from here, one node from here, one node from here, right? One node from end and one node from starting. I am saying that it is actually gonna end at the mid. It is actually going, the last node from the front side is gonna be the mid node. So if I take this as mid part and this as second part, right? So I'm saying that these are the two linked lists. This is going in backward fashion and this is going in forward fashion, right? These are the two lists which is going in front, this is going in back. So I say detach these two links, right? So 1, 2, 3 is one of my list. Let us say it is L1, and 4, 5, 6 is my second list. Let us say it L2. Reverse the L2 list. Reverse the L2 list. So it will actually become 6, 5, 4. And now proceed. Take one node from L1, right? Obviously, we will create a dummy node. This is my dummy. Now you will say that I'm using extra space. No, I'm not using an extra space because dummy node can be considered in O of one phase, right? A. Take a node from 1. 1 will come here, A will come here. Then take a node from L2. 6 will come here, A will come here. Then take a node from L1. 2, A. Similarly, 5, A will come here. Then 3, then 4. And you can see that this is the exact answer I want. I can just delete this node. I will keep my head here and I will return. I will return. And you can see 1, 6, 2, 5, 3, 4 is the exact answer I wanted for my uh, function to return true, right? Okay, so this is my part. First part is get middle. Already been discussed in the YouTube video. Okay, second part, reverse, already been discussed in the YouTube video in the given playlist only. I will attach the link to the videos also in the description. Third part, take one from each. Take one from each. That's all. This is the 3 steps you have to do. And I feel that you have got the hang of the algorithm, so we can move to the code of this. So guys, here is the coding section. But before starting with code, I would like to request you to please subscribe to my channel because it really motivates me, right? So let us start with the code. Our first statement is that if head is null or my head next is null, there is gonna be no change in English, so simply return, right? After that, find the get middle. That is, I'm do something like this: list node star previous equals to null, star slow equals to head, star fast equals to head, right? Okay. Now I'm writing the code for the get mid. If you don't know the explanation how to get the middle node of the linked list, please watch my link. Please watch the video. The link is present in the description. So while fast and fast next, what will you do? You will say fast will move 2 pointers. So fast next of next, and slow will move 1 pointer. Slow equals to slow of next. And previous before moving the slow, you will say previous equals to slow, right? Now break the connection with the slow, right? So list nodes star mid is gonna be my slow node, and after that you can just break the connection. So previous next is equals to null. So I got the two linked lists. As one of the linked list, that is what that was represented by L1 is actually now the head linked list, and the second linked list is represented by the mid. Mid pointer is the head of the second linked list. Now mid equals to reverse the mid linked list. So I will write the function for reverse now. So reverse is actually returning list node. So list node star reverse, which is taking my list node type, and let us name it as head. Now I will say list node star previous equals to null, and stem star temp equals to head. Now while my temp is not null, what will you say? You will say list node star next is equals to temp next. Then temp previous equals to temp next is gonna be equals to previous. Before traversing the temp, prev equals to temp, and then temp equals to next. At last return the previous because that is your new head, right? So this will reverse the linked list. Now create the dummy node for the answer. So list node star dummy equals to new list node with the value -1. You can insert any value. At last you have to delete only. So list node star a equals to dummy for adding the values. Now while my head and my mid both are not equal to null, what will you do? You will say a next is gonna be my head. A will now go for a next. The 4 steps we have already discussed in the playlist many times, right? Okay, then a next becomes, okay, first move the head. So head equals to head next, and a next is gonna be equals to null now. Do the same for mid. So a next is gonna be mid, a equals to a next, and now mid equals to mid next, and then a next equals to null. Now one of them becomes null and the loop ends. Now it is possible that either head is left or either mid is left. So just copy the loop again and again, and then for head do the above part only and remove the second part, and for mid do the below part and remove the first part, right? Now it has been done. Now you will just say head equals to dummy next. You can delete the dummy safely because that is no longer needed. So delete dummy and return the only return. This is a void type function. Let us try to run it. Hope it will run fine. Should not give any error. Okay, there is even error. There is a typing mistake. It is not double D. It is only a single D. Let us try it now. It is running fine for the sample test cases. It should run fine for the backend test cases as well. And it is getting accepted. So thank you for watching. Hope you liked it, and make sure to like and subscribe the channel, and we'll meet again in the new video. Till then, stay tuned and keep coding. Thank you. Have a nice day.